folks. So let's start by re-looking at the cloud reference model that Robert showed you earlier. And what I want to do is point out a couple of the areas that Robert talked about key capabilities, but these are the areas that we feel are attributes that are powering the underpinnings that differentiate us in IBM. And specifically, I'm going to walk through 10 unique attributes which support the capabilities that Robert talked about. So here goes. While I'm going to, do my best to keep this quick and briefly go through it, and why I think these are important, I have blogged about these recently. So if you go to Google and Google Cuomo WebSphere, you can read a little bit more detail about these, but I'll fly through them in a second. We start, and Robert mentioned this, standards. And IBM leads with standards because standards give our customers freedom of choice. And in our recent past, think about what we've done. This sort of freedom led us to record adoption in the industry of technologies like Java. And SOA is a key enabler, as well as pervasive technologies like REST, HTTP, and SOAP. Virtualization standards in the form of things like the open virtual format are also quite important. And folks, it's not clear that other vendors are thinking about standards like we are. And it's kind of a shame because these very same vendors collaborated with us, today with Java. So I'm going to encourage you to keep your vendors honest here and ask them about cloud standards. And like the panelists just a second ago, join us at www.cloudcustomercouncil.org. All right, virtualization is next. And pardon this because I grew up with a dad that is a physicist. Server virtualization introduces images, and to me, images are like atoms. However, to virtualize an enterprise application, we need to think about molecules, which are collections of atoms. And the interesting part about molecules are their chemical bonds. And in our case, these bonds represent the tricky configurations that make our components stand together in a topology. And we use patterns that prescribe and constrain the behavior of server components to ensure they come together just the right way. A pattern can embody years of best practices that you can read about in the various stacks of red books that we put out. But folks, who has time to read red books these days? So next, versatile clouds allow a variety of workloads to be consolidated under a single umbrella. And this is why we offer pluggable runtimes to support versatile workloads. Examples of workloads include enterprise runtimes like JEE, script-centric workloads like PHP and Ruby, and in a minute, Jason's going to demo a BPM workload and a few others. Yep. Workloads contain all of the IT bits that an application needs. So, for example, an app server, a database server, and a security server. Once we have the workload stood up in the cloud, the tenant brings their application and a set of policies, and the cloud does the rest. The policies are key. They define the behavior expected of the application, and it's key to make the workload run efficiently. Examples of policies include security, transaction, and scalability. Versatile deployments. Heterodeploytus is the genus name of a cloud that does not discriminate against target platforms. Don't Google heterodeploytus, I just made that up. IBM clouds support multiple deployment platforms. Again, it's not one size fits all. You just heard that a second ago. We support deployments on all the IBM hardware platforms, P, Z, X, as well as non-IBM environments. We call this bring your own hardware. Our private cloud can even mix these environments, allowing workloads to run, as Tim said, on the most optimal platform. Automation scripts and published interfaces matter, and they're key to supporting this level of versatility. And again, I have yet to see another vendor tackle this idea of design once and deploy to many. Elasticity. This allows a cloud to react to demand by adjusting capacity based on SLAs. The ability to grow and shrink, really to get the most out of your cloud. Think about things like utilization and performance. Data caching, replication are also really important to make this happen. Elastic data grids, database services, for example, embodied in our WebSphere Extreme Scale DB2 technologies, are integral to our cloud architecture. And this is especially important when your workloads are transactional in nature. Density. All right, hang on. I'm going to take out my tape measure here. One way I encourage folks to think about density is how many applications could you fit? How many enterprise applications could you fit in a square foot of rack space? Right? Multi-tenancy or shared middleware is key to achieving density. And we employ several very innovative techniques across our software to ensure a high level of middleware sharing. We also support the notion of singleton services, like a shared database, an elastic data cache, acting as a cloud-wide resource. Density also yields another important thing to your business: improved admin to tenant ratio, which drives down people cost and increases the accuracy of your deployments, hopefully allowing your people to spend time on things that really matter to your business. Again, challenge other vendors to take it to the tape. All right. Isolation is almost an opposing force to density. Isolation policies that we employ in Workload Manager dictate what workloads could be co-located with one another, and also how much dedicated resource is parceled off to a specific application. You don't want Macy's and Gimbals running, perhaps, in the same instance of a particular server. So our cloud architecture allows an administrator to balance isolation and sharing via policies. Security on the edge. Robert mentioned our partnership with Akamai. Right? It's critical to ward off unwanted intruders. So our cloud architecture employs intrusion detection, application firewall, and these are built in to ensure only the welcome are allowed to get onto your cloud. Resilient discrimination. The magic of automation and autonomic nature of a cloud in general puts an extra emphasis on resiliency. So the first key to resilient cloud is redundancy via caching and replication. But data analytics is also important, and it's critical to ensure that you have visibility. You can turn the lights on and see what's happening in your cloud, and actually gives you the know-how to recover quickly from a failure. And examples of this are intelligent log mining and proactive monitoring. Intelligent workload management, and this is something we learned back from the Z days. This governs work based on business importance. And it's actually a clever means to employ like a pressure valve in your cloud, and really to ensure that the most important work gets done first, especially during times of stress. Integration, and Robert talked about our cast iron product. Today, folks, you have choices in where you obtain your cloud services. For services that are critical to your business, you're going to want to build these probably yourself and run them in your private cloud. But for those services less critical for your business, you may choose to rent them from a public service provider. Integration is key to the success, therefore, of hybrid cloud computing. And specifically, the most common use case around hybrid cloud integration is data synchronization between on-premise and off-premise services. When you integrate between clouds, security, monitoring, governance are all essential. And these capabilities give you the control to responsibly distribute applications between clouds. And again, cast iron is our cornerstone here, and it pioneers hybrid integration by introducing libraries of thousands of predetermined cloud integrations for quick adoption of cloud services. And folks, last but certainly not least is simplicity. And simplicity is in the eye of the beholder. If you're a developer, if you're an administrator, or an application deployer. At the top of our list, in our architecture, we focused on a self-service, web-based portal. That's your first experience with our cloud, with first-class mobile support so that you can monitor your cloud from your cell phone. Next, as Robert mentioned, built-for-purpose appliances to assure simplicity when standing up a cloud. Rack it, stack it, bring your own hardware, point your appliance to it, point that appliance to it, and away you go. Now, while we support a bring-your-own hardware, rest assured here that we're going to continue to work on integrated workload-optimized systems. We've started to meld hardware and software into a built-for-purpose system for hosting private clouds that conforms to this very reference architecture. So enough of me